I think we're actually live at the moment. Oh, there we are. Okay. Assuming everybody can see me, please hit something in the chat box real quick. I don't know if we're actually live yet or not. Alright, I'm going to assume based on all the comments going that we are actually live. Somebody just saw I can see you. So this is our second end of the month live stream with the appropriate 1 minute of random technical glitches at the get-go. So we'll go ahead and get started with the questions in just a moment here, but just a bit of a highlight. If you haven't already seen it, this week's episode on the environments of space habitats already come out, and next week we will be working with the SENS Research Foundation to do an episode on the science of aging, which will come out Thursday at the usual time. And I actually have some folks who are helping me out with questions this time, because last time I got way far ahead, but I don't actually see those posted yet, so go ahead and start with the questions, and when those start coming in, we'll get started with answering them. In the meantime, if you haven't already caught the interview that we did with, I should say part one of the interview that we did with John Michael Gaudier, that is live, and you can find a link to it on the previous episode, Environment of Space Habitats, video description. I don't know for sure when he's doing part two of that, but we'll mention it when the time comes out. And first question, hey Isaac, how do Lagrange points work if a planet has multiple moons? That's actually a bit of a tricky one because, typically speaking, you're going to have one dominant moon that's going to perturb the others out. I think that they have tried to work them out for the Jovian system, for instance, but typically you start getting things synchronized in various orbits, so you get very temporary Lagrange points that moved around. Obviously, the solar ones can actually fluctuate a bit too, because you've got the ones that the planet has with the sun that are still being affected by the entire planetary system. So, for instance, if you had a bunch of them, all the moons lined up on one side of the planet, it can move with Lagrange 1, 2, and 3 points all very easily. All right. 1 second, please. Question. Do you know of Susskind's ER equal EPR theory, the idea of entanglement that is two linked particles via wormhole? I'm familiar with the basic theory. There's not really too much evidence yet to indicate that might be the case or not. It's nice. It doesn't break any FTL things. If you're wondering if there's some way we can use that for FTL, no, it just sends that one data point as it were that something is up or down. So there's not really any FTL options there. How we'd actually go about proving that is kind of tricky. I believe that would also be an example of what's called a naked singularity, which is when the event horizon would actually be too small to encompass the entire object. Next question. What is your favorite space-related feature-length film? Space-related, so I was about to say Blade Runner. I suppose Dune, the David Lynch version, might count after that. Those are two of my favorite movies growing up. I was really fond of Sunshine. Came out in 2007. And Sunshine, they're trying to restart the sun. Something's gone wrong. They have this big payload to take in there. And it's a very good movie, except the last third of it or so, it seems like they were trying to make a bit of a horror movie instead of just sci-fi. And I don't think that worked quite as well. But it might have been one of those cases where they worried about coming out too cerebral if they didn't include some action. Question, are you going to make a space company? I can't see myself doing that anytime soon or getting involved in something like that. It's really not... entrepreneuring, I like doing the channel. It's pretty much as simple as that. This is fun. Running a business, the channel itself is a business, so I suppose that counts, but running a business, not so much. I wouldn't want to, it's nice to get involved in those projects, but not to have to devote yourself entirely to them, and with anything like that, it's going to eat up all your free time. And yes, Larry, I'd agree, the Dune audiobook is a good one too. It's one of those ones that's got a full feature cast, so you get to enjoy many different roles. Question from Lin Yan Chan. What do you think of depth psychology? I actually don't know what that is. I'm sorry. Hi Isaac, what would happen to an orbital habitat near the speed of light? And I think we'd presumably be talking about something like a ring world if it was a larger one that was spinning around so fast that it was at relativistic speeds. I don't think you'd actually have any real problem with that. You just have everybody on the surface having about the same actual time dilation. So they would actually see a lot of blue shift from anything, sorry, red shift from anything coming in light-wise. But other than that, they'd just be going a little bit slower. All right. Next question we've got. Could hypothetical extra dimensions be of any practical use to us? I was thinking of Hammer Space. If you're familiar with the old Looney Tunes cartoons, they pull the hammer out of nowhere and then whack something with it that got to be called Hammer Space. You'd probably be familiar with it from the TARDIS for Doctor Who, where it's bigger on the inside than the outside. If you can find some way to do that, that would be incredibly helpful. As to other things, just an example, if you could move stuff from 3 dimensions into 4 dimensions real quick, you might expect gravity to be a lot stronger there because it might be a all cubed force, so you might be able to do fusion easier, for instance. The physical laws would be very different, assuming they were even parallel to the ones we have here. I have to assume you'd have some way that could be useful if you could actually make use of it. Clay Behrman asks, if a spacecraft could travel at light speed or faster, what would the gravitational effects be of traveling into a black hole? Basically, would spaghettification still occur? As you're approaching any solar mass black hole, I mean specifically ones in that area, you have a tidal force that's so strong that it's going to rip you to pieces before you get to the event horizon. Not all black holes have that. The smaller ones aren't strong enough that we could conceivably make artificial ones. They'd be too small to exert that kind of force on someone. And the really big galactic center ones are too big for them to have the tidal forces that rip you apart before you hit the event horizon. You would still be subject to that, though, unless your ship drive in some way played with gravity, which would not be too surprising if it was an FTL device, I would think. Hydrogen Cyanide asks, when do you think we would get when do you think we'd finally get fusion power and fusion-based rocket engines? You know, the old joke with fusion is that it's the technology of 20 years from now and always will be. I think that it's getting a lot closer, but, you know, I think if we say 20 years from now, right now, that might actually be true. I should point out, of course, that we already do have fusion. We've had that since we invented the H-bomb. And they're all ship drives like the Orion or the Daedalus design that do actually make use of that. And so those would be fusion drive ships, post-nuclear. As to when we'd actually get some nice compact fusion drive, you know, your guess at this point is as good as mine. The research on that has been pretty impressive, both with tokamaks and all the other variations, but who knows. Question: dark energy accelerates galaxies, why does it not run out? And does dark energy threaten the law of conservation? I assume you mean the law of conservation of energy, and no, it doesn't threaten it at all. It just completely kills it. For that context, if you get into general relativity, even before we knew about dark energy, you already have an issue where basically the law of conservation of energy was, I don't want to say thrown out, but limited in terms of the scope a little bit. A cosmologist could probably explain this a little bit better, but dark energy does violate conservation of energy locally, but it's really spread out over time and space, so there's no practical way to take advantage of it that anyone's been able to think of. It's not that conservation of energy is wrong. It's same as Newtonian mechanics isn't wrong either, just because we have special relativity. It just has to be extended to those kind of math. And it is a lot of math to really get into that, so we'll skip that for today. But conservation of energy, it's kind of same with entropy. Just because you find one kind of specialized case of violation doesn't make it wrong. For instance, if we're assuming the Big Bang created all that energy in space out of nowhere, although time's a little bit of an iffy thing there, you'd have at least one violation of both entropy and conservation of energy right there. Doesn't mean you can make a perpetual motion machine, though. Question: hypothetically, if you had an Alcubierre drive and accidentally hit a hopefully uninhabited planet, what would happen? The Alcubierre warp drive concept has some problems in it that they think that when you're going to arrive and you accelerated, you basically blow up the thing you're going to hit. It is a lot of energy involved in that sort of thing. That's why I would say with FTL that it's not just a question of if you can do it, it's whether or not you'd ever have the energy to want to pay for it. and it is a lot of energy, even compared to relativistic ships. But you do have the other problem with the Alcubierre drive is you got a white hole in front of you and a black hole behind you, so you can't really steer. That can confuse people sometimes. What it is if I'm moving faster than light, any light behind me that's trying to catch up has an effective event horizon because it never can catch up. So behind me is a black hole for all practical purposes. But again, I think everybody on the channel knows I'm really not very optimistic about any sort of FTL, including the Alcubierre drive. Question: what are the applications of nanotechnology and how far off is it? We actually have an episode that's going to talk about that a little bit in mid-December, the Santa Claus machine, which is one of the names for that kind of technology. And as to when we'll have nanotechnology, we kind of already do. Loosely speaking, we'd say the biological scale, even all the way down to viruses, still qualified as the microscopic scale, and that the nano scale is really when you're starting to get into ranges where atoms are part of your basic resolution and building blocks. We do already have a lot of technology with carbon nanotubes and graphene and so forth that actually do that. Little needles, things like that. When that will actually turn into what people tend to think of as like the self-replicating robots, that is going to depend probably on when someone can actually make a replicating machine of any type first. And I tend to suspect you'd see microscopic ones first, possibly using biology as a baseline or even hybrid in it, and then kind of going down scale from there. We'll have to see. And we do talk a little bit more about the problems with that in terms of like the Drexler-Smalley debates in that December episode. All right. Do you have a favorite new space physics series movie? The Expanse would be, but I guess it doesn't really qualify as new with 3 seasons already under its belt. I was getting kind of fond of Lost in Space after I rewatched it a few times, and The Orwell, which I'm looking forward to a second season of, but that's probably about the extent of it for right now. There's a lot of good sci-fi out there, a lot more than when I was a kid, when you basically were lucky if you got one show, but as to having a personal favorite at the moment, I'd probably say The Expanse. Evelyn asks, do you play any space games? I am almost always 5 to 10 years out of date on video games. I got around to playing Mass Effect only about 2 or 3 years ago. I have not played Stellaris yet. Well, I have played it. I just only played it for about 30 minutes a couple times and didn't get too into it. Good game, but I didn't feel like learning the various layouts and consoles. As for the newer ones that are coming out, I mean, I hear about them a lot, but I've not actually played very many of them. Let's see. Question: can you tell something about cryonic preservation for people that want to do mind uploading when the technology comes? I'm going to interpret that as, could you use cryonics to preserve your brain against a day when they might be able to scan it to be able to upload it into a computer? Yes, probably. I mean, the stuff that should be damaged when you're freezing, assuming you're doing it properly, should leave your neurons in good enough condition that we'd be able to scan them and see what their state was. But we really don't know how mind scanning is going to work yet. There's a lot of debate on what you actually need to have as your scan resolution to get what you need out of that. And we tend to think you could probably do it with about 10 to the 16th hertz by just modeling every neuron's behavior. But there are other arguments that say it's going to take more. See the mind uploading episode for that. But a good example of that would be the Barbaverse series, I Am Legion by Dennis E. Taylor, which I think was our book of the month. No, I'm sorry, one of his other books was our book of the month. We've mentioned the series on the channel, though. It's a great one to read. That's actually probably my favorite new sci-fi series in terms of books. Question from Xavier Cavanaugh. For heat removal in space, is it possible practical to channel waste heat to heat sinks and use it as a power source? Probably not. The problem with almost any type of heat engine is that you need a colder spot and a hotter spot to go by. Now, with the example like a Matryoshka brain, each layer is getting successfully cooler, so you can use the radiation given off by the previous layer to generate power. But there's a certain maximum number of layers where that can really be effective, and more or less if you're cutting by less than half the temperature of the previous layer, you're not really getting much gain from doing it that way. it always has to be cooler for a heat engine specifically. There are usually other limitations that are going to cause problems after that, though. 1 second. Okay. Do you see potential in the Nova engine project? I mean, obviously, yes, it's a good one to have going on. It's just, with so many of these, I am not a rocket engineer at all, so I don't really like to say which ones are better or worse. Here, we mostly just try to introduce you to ones that people are less familiar with. I would say, especially for anything off Earth itself, that the area that we want to be looking at using is atomic rockets in general, again, away from the immediate area of Earth, just because they give you that option for a lot of delta V, and for an actual decent thrust, in combination with an ion drive or not. Question from Andy. Which would you prefer and think would do first? A calling on a planet or a rotating space station, and which would I prefer? Probably the rotating space station is the first thing you have to do. Realistically, if you wait to go to... I mean, we can go to the moon where the gravity's lower, and we don't really know how low gravity affects people, just zero gravity and normal gravity. We can go to the moon, and if people start having problems, we can bring them home. It's a short trip. Even Apollo only took 3 days, and we could do it faster if we wanted to. When you start talking about places like Mars, that's a very long trip, with a very long time on the ground, to find out if low gravity, like Martian gravity, is bad for some of the processes we need to do there. And you can do a space station in orbit around Earth that's got lower gravity and check it that way first by having a spin habitat set to moon or Martian gravity. There's also, the spaceship that goes there to Mars, anything like that, unless you're trying to do it really small, needs to have that rotating environment and that sustainable recycling. Again, unless you're doing it very small, you kind of want to do all the stuff you'd be doing on board a smaller space station first. And that is the majority of your trip. You are spending more time getting there and back than you're spending on the ground with a typical method of getting there. So you are more modeling what's happening on board a space station, i.e. a spaceship in this case, than you are what's happening down on Mars. So it does make sense in my mind to do a space station first. Plus, unless you just want to go to Mars to plant a flag, I really feel like you need to have a space infrastructure set up first. We'll talk about that more in a couple weeks for Battle of the Moon. Question from Gorham. Would a dark energy engine be possible, and could it go faster than light because dark energy allows the universe to expand at an increasing rate? Dark energy does not allow you to do FTL at all. It's just creating new space in the middle of things. So there's no FTL option implied by that. This does not mean you couldn't actually create something that ran on dark energy. And, of course, if you can figure out what it's doing, where it is adding space, if you could figure out some way to do the reverse, to cancel space out in front of you, then that is kind of like the warp drive, where you're compressing space in front of you and putting it behind you. And that actually is one of the examples of FTL that cheats and lets you actually do it without actually breaking any rules. As to a dark energy engine that actually created a power, like I said, it probably violates in conservation of energy, at least from certain perspectives. So you should theoretically be able to tap it for energy, but how anyone will go about doing that is very hard to say. Okay. Question, is graphene or graphene oxide bound in a inert plastic toxic in our body? Not that I'm aware of, but I don't believe anyone's actually produced enough of it yet to be able to do longitudinal tests. And asks, are you really a CIA agent? No. I actually have worked with them in the past in Iraq, though. They're all polite fellows. Question, what would happen if negative mass, i.e. an Alcubierre drive, not antimatter, met a black hole? Would the singularity lose mass? Could you kill a black hole? Again, it so much depends on if we actually have negative mass, what it is, but that's how Hawking radiation works, is you've got two particles appearing, one negative mass, one positive mass at the event horizon, and the negative one falls down, as it were, and decreases the mass of the black hole. At least that's one way to interpret it. Virtual particles are iffy to call real. So if you had a big chunk of negative mass and you ran it into a black hole, yes, that should decrease its mass. Typically, these ships all seem to have a net positive mass, ditto for wormholes, so I don't know that you could separate that negative mass off and throw it in there. But yes, in theory at least, if you have a big chunk of negative mass, that is one way to kill a black hole other than waiting patiently for it to burn out. Question: what can we do as individuals to push the progression of colonizing the solar system? In terms of talking to governments or Congress, obviously, if you live in one of the districts where one of the congressmen sits on the space committee, sending them letters is probably most effective. But you just advocate for it, try to explain its value to people, try to build up enthusiasm for it. Congress in general is mostly pro-science and space, so their biggest concern is, are they throwing this money down a hole? Because $1 billion here or there starts to add up, and there is a lot you can do with it. And if we invest in really big projects, the worry is that people will not see a value coming out of that and object. Question: do you think any biological life capable of traveling through the space without spaceships could evolve? I was thinking of the Tyranids from 40K, or the bugs from Starship Troopers. Not the book Starship Troopers, the movie Starship Troopers. That sort of thing, or like Moira from Farscape. That would be an example of one that would be a little bit more realistic, where it was an organic or effectively organic ship that had been engineered for space. And it is something that we'd like to look at probably next year. We'll finally get around to doing that because we keep putting that episode off. But I don't think anything would naturally evolve there. You should be able to make something that could live there, but it's just not a good setup in most places for anything to actually, no atmosphere, no liquids, very hard to evolve there. And again, it wouldn't count if it was inside a comet any more than it would count when it's on a planet. Question: how realistic is a generation ship around 3 kilometers long and half a kilometer wide with a population of 1 billion? It's that last one with the population of 1 billion that's a little tricky. That's smaller than most O'Neill cylinders, and we usually think of O'Neill cylinders having a population of around 1 million tops. So trying to cram 1 billion people in there that were natural people with, that weren't running out of electricity, that would be very difficult. I don't think you could do 1 billion inside one of that size. You could build one that was wider and longer, like a McKendree cylinder, that could conceivably do it, but I don't see fitting 1 billion people on board one. Not for that size. Even if you had multiple layers, you start getting that heat loss issue. You can't get rid of the heat fast enough. So I don't see one that size being able to handle 1 billion people. Question: do you still work as a physicist? If so, what is the focus of your research now? And do I have any advice for first-year physics students? I do not actively work inside the field and haven't since I left to join the Army. I had kind of thought at the time I'd probably go back. A lot of people stay in the military and continue in the field too. In fact, my internship with the Air Force way back in the day was with a lot of colonels and majors who were PhDs in physics or engineering. And they are active in academia too. I can't see myself actually ever going back into academia. I guess you could stretch a point and argue that I still work in the field now by doing stuff like this, but it's I have no desire to go into active research again. I get bored with projects too fast, and while I love teaching, the idea of having 30 students in a room again, most of whom do not want to be there, versus having an audience of, I have no idea how many people are watching right now, but more than 30, I'm sure, who actually want to be here. Just in general terms, I like what I do now more than that as an option. As to advice to first-year physics students, actually, most first-year physics students are busy taking various calculus classes and maybe the University Physics 1 or 2 course, so they don't need too much advice other than get in the habit of doing your homework. As you get into second and third year, coffee is the greatest invention mankind has ever made. You will want that. Most people who go into the field are used to doing their homework and studying for maybe a few minutes per week, as opposed to the length of the class. By the time you finish out your major, even if you're a valedictorian in it, you'll be spending twice as much time studying and doing homework as you do in the classroom. So it's often a little bit difficult for people to adjust to having to really work for the grades. Question. In space, there is an aspect of harmful radiation affecting living organisms in terms of both functionality and longevity. Do you think we need to address that from a biotech point of view? If we can, we should. Again, that's actually kind of one of the things we're talking about in next week's episode, because radiation and cancer is such a big factor in human mortality nowadays. However, space is a radiation-soaked hellhole, and the best way to get around that is to do a lot of shielding. On the other hand, most of the drives that actually let you get from point A to point B that are on the table are atomic in nature, so you've got radiation inside your ship too. You definitely want to be good with dealing with radiation because it saves you mass on shielding, but in the end, you're still going to use as much shielding as possible. Question from Capital H. If you're right and we do not break light speed, will humanity use relativistic effects to make one-way trips, especially if we extend our lifespans? There's always an energy concern on traveling fast. It takes a ridiculous amount of energy to get up to any speed that's even a little bit relativistic. Like, even at 10% of light speed, it's very minimal. I mean, you'll be able to notice it on a clock being late, but you wouldn't really notice if you were talking to someone on the phone that much. Every little bit you get faster, even ignoring the usual extra cost on things like the rocket equation itself, you have to start increasing the energy using exponentially. I don't think anyone going, I think it's 80% is about when you hit a 50% time dilation. And then I think you have to get up to around 90, 95, I want to say, to get down to 1/10 the speed. That's a lot of energy for what's not saving you much trip time objectively, just saving you personal time. And I think most companies looking at the fuel on that are going to be thinking, well, why don't we just put you into hibernation, or why don't you just enjoy the trip? But certainly if you start looking at trying to do intergalactic travel, you're going to want as much time dilation as you can, just to, if nothing else, help preserve your machinery a bit, because they won't be decaying as quickly. Question, have I talked about quantum tunneling? Could it be used as FTL? I have talked about quantum tunneling a little bit. Can it be used for FTL? Not in any meaningful way. Quantum tunneling is, in its simplest form, it's kind of, I guess we use the normal analogy here. You're standing at the bottom of a hill, and you have enough energy to get halfway up the hill, but you can't quite get to the other side of the hill. With quantum tunneling, there's an uncertainty about how much energy you actually have at that scale. So it looks like you only have enough energy to get halfway up the hill, but it might turn out that you have, because of uncertainty, just enough energy to get across the other side of the hill. And that's kind of what quantum tunneling is in a short form. There's no aspect of that really involves faster than light travel, though I suppose you could argue spooky action at distance. There's an uncertainty to your position and energy, and that's what's allowing that effect. Question, do you believe we live in a holographic universe? It's not a bad theory. This is one of those ones where it's like string theory, or we were saying ER equal EPR for quantum, Susskind's theory earlier. Until I see experimental evidence of these things, I don't object to people theorizing about them. It makes for good papers, but I really don't like to discuss them too much outside of that specific academic circle, because it can result in a lot of hype, confusion. There's nothing to prove that might be on the table per se. Same as with multiverses versus Copenhagen interpretation. There's no proof one way or another. Good theory, but that's about the extent of it. Question, do you think it's possible that we might cure aging as a byproduct of adapting humans to zero-G and radiation, since astronauts seem to age faster? Well, there's arguments that you actually are aging slower in some ways in low or zero gravity, which we'll actually discuss a bit in Battle for the Moon. But again, we do have the episode on the science of aging coming up this Thursday. That's going to talk a lot about how this process works. And one of the biggest ones actually is treating radiation and cancer. What we think of as life extension technology and what we think of as medical cures for diseases more or less overlap. There's really not a stark contrast. Do you think it is realistic to uplift an animal species by breeding them in a McKendree cylinder and applying... I really hate when this window always moves on me. And applying selection pressures to cultivate intelligence. it kind of feels like it's separate questions, because could you put a species inside a McKendree cylinder? Is there enough space? Again, a McKendree cylinder is kind of a very large rotating habitat that's got about as much internal area as a large continent. So that's certainly a good amount of space for a species to grow up into, unless it's bigger than elephants. If you uplifted it, could it live comfortably inside there? Sure, but questions you always have to keep in mind when building a habitat like that. If you're trying to put them at a primitive level to begin with and see where they go, where are they getting their metals from? How are they doing astronomy when they're inside something like that? So, question. I'm extremely interested in both astrophysics and artificial intelligence. What would you suggest to study in college? Is studying both a good idea? There's really not that much overlap between astrophysics and artificial intelligence besides our interest in it. Folks who tend to be interested in the one tend to be interested in the other. Von Neumann probes would be obviously one of the things you'd most be looking at with artificial intelligence and astrophysics. If you had to pick which one to study, could you study both? Yeah, you could. A lot of physicists have a minor or a dual major in math. You usually have to take one extra course to get your undergraduate in math if you're doing physics. A lot of mathematicians have a minor or major in computer science. I don't see any reason why you couldn't do all three. It wouldn't really involve that many more classes, though you probably have enough accumulated credit hours by the time you finish those three out to have a master's in one of them, and it usually is better to aim for that one higher degree first, unless it's almost a freebie, which is like for math as a dual minor. Because, again, degree is really saying what your threshold is for how much you can study through. After you're done with that, you know how to learn. You can learn anything you want. If you're doing it right, you will get to the point where you can read a textbook almost like it's a novel, and you can just learn the subject more on your own. Question. Can ability to build space habitats be considered a human evolutionary trait? I'm kind of going to interpret that as, can we think of humanity as kind of the Earth's evolutionary mechanism for spreading out to other ecosystems? A thought on that is life in general wants to go to additional niches. Presumably it started off near a thermal vent or tidal pool and slowly worked its way out to increasingly bizarre and often extreme environments. And you could think of intelligence and technology, I suppose, as an evolutionary mechanism for spreading to space environments or to other worlds. But that's arguably semantic and certainly subjective, but it's more poetic. Is the digitalization of consciousness feasible in the next 50 years? Probably not in terms of actually being able to do it. Not because it's necessarily a really huge advance technologically, as you have to do sequential experiments. You think about, again, something like fusion, people always wonder why it takes us so long. And a big part of that is every time we want to learn something new about it, we often have to build a brand new facility that takes a decade to get funding, and a decade to construct, and 5 or 6 years to get that first elementary data out of it. And, that whole 20-year period when you're doing that, not much else is getting done on that front. You can still do some theory and a little bit of experimentation, but you have to wait. And I think we're going to find that's the case with human consciousness a lot too, because every time we go do a new step on that, there is going to be a regulatory, ethical, barrier that says, show us this is safe to do to people. Show us that this is not going to create a crazy, half-conscious mind. So I think there will be a lot of steps in the middle that people have to slowly meet before they'll be allowed to proceed to the next one. Okay. And let's see. Okay, we are going to take a quick break, see if this hopefully works. So while we were taking a quick break, which incidentally is a great chance to grab a drink and a snack, as I am presumably doing myself, I want to take a quick moment to give a shout out to a new book by our friends over at Universe Today. Fraser sent me an advanced copy of it a few weeks back, and it came out this week. The Universe Today Ultimate Guide to Viewing the Cosmos, Everything You Need to Know to Become an Amateur Astronomer, by David Dickinson and Fraser Cain. And it's a great primer on getting into amateur astronomy. I think I've mentioned it in passing before that way back when I was in grad school at Kent State, I got tasked with running our school's observatory for some of our public viewings. And I'd imagine we have a lot of folks here who are amateur astronomers or who have been thinking about getting into it. If you are, I'd grab a copy. It covers everything from how to pick the right telescopes to how to use it, and even how to do photography with it. If you haven't seen them before, you can also check out our collaboration episodes with Fraser on colonizing the solar system and Kardashev 2 engineering. And if you're in a shopping mood, you can also swing by Signal and grab yourself an SFIA t-shirt or mug, and I'll include a link in the episode description. Lastly, while we'll try to get to as many questions today as possible, if you don't get yours answered today, you can always join our Facebook or Reddit groups, where I'm often around to answer questions, as well as our Discord server, where we tend to have a live voice chat on Sunday afternoons a couple times a month. Those will also be linked in the episode description. We'll be back in just a moment. Okay, and we are back. I did notice somebody mentioned there the volume on the break there was a little on the loud side. Normally I normalize the volume on the videos to a -4 decibels, and that makes my voice a little bit louder when it's compressed too, so I'll be careful with that for the next time when I need to take a break to not smoke a cigarette. Question. If you spin a huge amount of mass, will it create a synthetic ergosphere, and is it so? And can you use this as a warp drive because it will warp time? There's a question that often comes up when you're talking about something like a neutron star, which is really close to being at the edge of a black hole, level of density. If I accelerate that up there, will it turn into a black hole? And this is one of those things we get into the rest mass issue. Rest mass, we usually only use rest mass. Your mass technically increases under relativity, but we usually treat that as not increasing. The neutron star itself is not collapsing into a black hole from the acceleration, because it's only its localized rest state that matters. Alternatively, you would actually see an event horizon if you pushed away from you fast enough, because it's redshifting away. Any object that's going fast enough can eventually have an event horizon relative to you where you're not seeing it, because it's just getting redder and redder and redder until it effectively disappears over the cosmological event horizon, for instance. If it's got a lot of gravity too, it's redshifting that light as it escapes from it, and that would add up to that, cause it to have an event horizon sooner. Let's see. Pineapple asks, do you think it would be possible to have a minor, partially self-sustaining colony on the moon by 2035? It depends on what you mean by self-sustaining. I think we could have a base on the moon, potentially even in this upcoming decade, though probably not. 2035 seems a little early for any kind of serious base that was actually self-sustaining. However, it all depends on the technology that's letting you do that. If tomorrow somebody creates a clanking self-replicator or design for a very simple power satellite beaming system like we discussed in power satellites, that might be all you need is that push. It is one of those things where a lot of these time estimates have to do with kind of a guess as to which technologies are going to roll out, and there's so many of them that affect launch costs that you're just kind of assuming a sort of a loose... It's like guessing the stock market way in advance. You see an upward trend, and from that you're extrapolating 20, 30 years. It's one of the reasons I don't like doing the 20, 30 year type estimates, how far advanced it's going to be, besides the fact that it's almost always wrong. What you can say is, if we get X technology, then we will have this, say, 10 years later, because about how long it usually takes to do prototyping and funding. Create a clanking self-replicator, or get launch costs down to hundreds of dollars per kilogram, and I think you'll see a moon base within 10 years of that. How has my opinion on blockchain technology evolved since the cryptocurrency and blockchain video from 2 years ago? To be honest, not that much. I have a certain grudge against cryptocurrency because a show like this relies very heavily on graphics, and that means everything we do relies on graphic cards, which are insanely expensive right now because of cryptocurrency. Blockchain is evolving to be something very useful. Cryptocurrency, the same basic arguments are involved. It's It's not a fringe technology anymore, though. I think cryptocurrency is something here to stay. I don't know how big of a niche it's going to have, but it's not a fad technology. It may grow into something much bigger. It may shrink down to something smaller than it is right now. I do think it's here to stay, though. Question about science and politics. How could we push the international community to work together to build an orbital ring? At the moment, I don't think that you could. An orbital ring is one of those things that you build when you already have a very large space infrastructure. There's not that many advantages to doing them before that, just because it's just like building a railroad track between New York and San Francisco. That's profitable right now. It wouldn't have been profitable in 1802. And you have to wait until there's a lot of infrastructure and need before something like that's really justified. Something a little bit more limited like a Livestream loop, maybe sooner. I think that is going to be an issue, though, when you ever start looking at things like space elevators or orbital rings or even Livestream loops. There's a big right-of-way concern. It's often going to be over other people's territories and not just orbiting over real quick either. And so I think they're going to want permission or access, and you're going to have to negotiate with them on stuff like that. Plus, it's always nice to be able to have more resources, more brain power available. And if you can get other countries to toss in on something like that, it's certainly going to speed things up quite a lot. So, but I think that's one of those things that will solve organically with time. Same as the space treaty, the outer space treaty, that probably needs to be revised at some point, but we'll see how that goes. A lot of times we don't even know what needs to be changed on treaties like that until we get closer to the current actual problems and context that they're in. What is the subject in physics that you struggled the most to master or understand, either now or in college? Electrodynamics. My professor for that had told me that the answer when we start the class off is either always going to be 0 or not 0. Which is often, in many cases, if you're doing electromagnetism, the answer is actually 0. Everything nullifies out. I do not like electromagnetics. I mean, obviously it's an important field, but I never feel as intuitively comfortable with it as I do something like classical mechanics or relativity. Electrodynamics can obviously be electromagnetics for undergrad, electrodynamics for grad school. I know a lot of folks have problems with quantum. That one didn't bother me as much, though that's a hard course too. Solid state can be hard too. You tend to have to adjust your intuition a lot on these things, but once you learn them, it seems strange that they were hard in the past, and it's hard for me to remember which ones I had more problems with or less problems with back when I was first learning them. Question. Would you be willing to do an episode on the future of spacesuits, especially as a second skin, something you could wear during long flights? I would be willing to if there were the visual assets available for it. It's actually a fascinating topic. I wouldn't mind covering it as maybe battle armor too. Although whenever we start thinking about power suits, I start wanting to do one on mecha and robots. We talked about how those would never be practical. That always gets tempting to revisit that though. A lot of times episodes, if there's not enough visual assets there, I don't really like to do episodes on them because it feels like it's just me talking. A lot of these ideas work so much better if you can actually see them. But there is a lot of material on spacesuits and their relevance, and don't always think of it as necessarily a spacesuit either. You get something like a second skin, something that's as comfortable to wear as just your normal clothing. That's not necessarily just going to be in space that you'd use that. You might use that on the ground. I mean, I fully expect us to have an increasing amount of electronics and nanotechnology built into our clothing as time goes on. You have to have a certain length of antenna to get reception. How much easier would it be if your antenna was built into your clothing? With so many of these things, what if you have climate-controlled clothing, things that recycle it, and recycle moisture from your body, for instance, something with solar panels integrated into it, kind of like a chainmail, if you would, that could charge all your apps or appliances or create a very small Wi-Fi field or electric field that you could charge those things off of. The technology of spacesuits and clothing would be a fun topic, I think, to cover at some point, but we'll see how that goes. Isaac, what is your opinion on weak values in quantum mechanics? Can it make FTL communications possible with quantum entanglement? I just do not see a scenario for quantum entanglement allowing faster than light communication of any kind. Some people can debate otherwise, but I've never seen the argument really backed up with anything I would say is solid. Experimental data on something like that is always the key. If somebody can show me an experiment where they have sent one single bit of data to another location faster than light, I will change my opinion on it. We are getting a lot better with quantum entanglement, though, obviously, and that has an effect on quantum computing, too. Question. If you would or could decide somewhere in the universe to be teleported to, which location would you choose? I'm trying to think of a place you could actually be teleported to besides Earth that wouldn't instantly kill you if you were sent there. I would not mind. If I had to pick a place I could be teleported to and be alive and make a return trip, I would really like to be on the other side of the galaxy, on the other side of the zone of avoidance, so we could take some data of the other bits that we're missing. There's a big chunk of our sky, which includes an awful lot of other galaxies, because the center of all galaxies is in the way. There is a lot of our galaxy we can't see because the disk and the core of the galaxy is in the way, and there's a lot of very interesting things like the Great Attractor that are stuck behind there, so that would be a good place to get some data. And of course, failing that, teleport me to Mars so I can plant a flag and get my name in the Guinness and all that. Question. Why don't we make the sun last longer by adding hydrogen and helium? If you actually just added hydrogen to the sun, you would not lengthen its life. You'd actually shorten it down. If you are pulling helium and other things out of the sun and replacing that with hydrogen, that would extend its lifespan, because it doesn't really run out of hydrogen, though it can after a long enough period of time with like red dwarfs, for instance. It just starts getting choked with helium, and the bigger ones, they get choked with carbon, eventually even iron, and detonate. That is a way to extend star lifetime, though. We did talk about that in Starlifting and Dino, the Civilization of the End of Time, Episode 3. Regarding weapons in space stations and craft, do you believe we will continue using projectile-based firearms, or would that be too dangerous in that scenario? Whenever you're talking about firing off weapons inside of a spaceship, your biggest problem is that you're worried about putting a hole through the wall. And you say, so we need to use some weapon that doesn't put holes through the hull of the ship. The problem is that unless the hull of your ship is thicker than people's body armor, there's no point having weapons to shoot at them anyway. Someone's going to be coming in a spacesuit. They're going to be wearing armor. If that armor is thicker than the ship of your hull, you can't use a weapon on them that isn't going to penetrate your hull, because you won't be able to penetrate their body armor. So I think you would always have fairly thick hulls on ships that were expecting to have hostility. And then if you're just talking about somebody trying to maintain authority or chain of command on board a spaceship, use a normal pistol. Let's say you shoot them and you put a hole through the wall. It's a small hole. You can go over and plug it with your finger. It just slaps something over top of it and seal it over. Leaks in spaceships of that size are not a big deal, except for when you have them behind some piece of equipment so you can't see them other than they're sucking air in. If it's just a hole in the wall, you walk over, slap something on top, and then go seal it. Question. If we were going to live forever, what would be your preferred mechanism? Mind upload, medical technology that makes your physical body indefinitely lasting, something else? Personally, my ideal would be something that just extended my own life, preferably with a little bit of augmentation that allowed it to be communicated some storage space digitally, so that if something did happen to my body that was beyond retrieval, they could boot up a copy of me. And I would regard that as a copy, but that copy would still be able to do continuity. Could still go to my friends' birthdays, still consult for them. It could still run the channel, that kind of thing. It might not be me, but it's a pretty good successor. Question. One moment, let me scroll up. How do you think galactic trade would work, considering the logistical problems with trade or exchange of goods? Which would it be even worth trying to colonize planets which are not completely self-sustaining? There are things you can trade between solar systems. It's harder, and it would be more of a niche, I think, but you can even send raw matter to them. If you're doing a Dyson sphere, a Dyson swarm, you do have enough raw materials in your own solar system to do that, but you still might want more raw materials, and it probably is still energy cheaper to send them slowly, because it's a long construction project, so you don't need to be fast, to even send things like rocks to another solar system as raw material. And And then, of course, you've always got your oddball goods. There's always going to be somebody who's going to pay for a rock from that other solar system, or the first minting of their local coins, or the first edition of some comic book. How much would somebody pay for a glass of Regelian wine? All that matters is whether or not that wine was cheaper to ship there than they were willing to pay. And when you're dealing with something as big as a Dyson swarm, you're almost certainly going to have enough people and enough post-scarcity environment for someone to be able to afford to buy those at outrageous prices. But then, of course, you still have your one big one, which is data. And, that's still a trade thing. And you wouldn't always necessarily send that with lasers either. The assumption is you transmit it on a tight beam to that system. There are limitations to how fast you can send data, and there'd be a lot of things that might just be so large, but not really time relevant, that you might actually send them on a hard drive. You don't really need to get the movies from another solar system a year faster, and they might be gigantic high-resolution things of quadrillions of gigabytes, and so that might be something you send on a hard drive too. Question, will you ever do a more in-depth discussion on gravity, both spin and regular? We do talk about spin gravity a lot. I tend to feel like I repeat myself. Every time we do an episode on rotating habitats, I'm worried I'm boring the heck out of people by discussing the same point over again, but we try to keep the episodes internally contained. When we do the Flat Earths episode, megastructures, flat Earths, we're not talking about the Flat Earth theory. That episode, which I believe is the first one in December, we'll talk a little bit about some of the stranger aspects of gravity when it's not in a spherical format. Beyond that, though, I'm not too sure there's that much to discuss. I'm never going to do a general relativity episode on this channel. We can talk special relativity, because you knew that with algebra. For general relativity, there's just too much of a math background. And there's many good courses that explain that topic to folks, but nothing we could do in a 30-minute episode. Question, do you think the Hyperloop will be successful for mass transit? There are, this is the thing, the Hyperloop. There are actually several Hyperloop projects going on. They're not all the same. You have two big cost issues with that. First is right-of-way. If you want to build a tunnel overland or even underland, you have to secure all that right-of-way, and you can go back to looking at the history of the railroads to find out how hard that was in a country where most of the land was still undeveloped. As to the other aspect of that is there's a cost. When you're trying to make a big tube, it has a crush pressure that, a vacuum between one atmosphere is not very large, but when you start making these pipes, you get this expanding extra weight that you have to deal with, and that's manageable, but it requires very thick pipes, and it also requires a lot of joints to connect everything, that all of which gets kind of expensive. If there's enough demand for it, yes. If the price to manufacture those gets cheaper, yes. If you get a material that handles that better, yes. As it is right now, maybe. You'd have to ask an economist. I'm not in a position to say yes or no. I think that there is a definite place for vacuum trains along the lines of the Hyperloop in our future, but that assumes much cheaper manufacture, much cheaper tunnel boring, for instance. Question, do you think antimatter propulsion might become a reality in this century? Probably not. Until somebody finds a way to actually produce and store reasonably safely large quantities of antimatter, and we don't have a mechanism for that right now, it's not going to be a very good drive. It's the ideal ship fuel. There's no getting around that, but it is, I think we spend about 10 million times as much energy to make it right now, and the whole point of the stuff is that's really nice in terms of its net energy that it produces. Maybe down the road, but to me it still seems like it would be so much easier to do something like a Laser, even if you didn't have something like fusion on hand. And I think that's probably going to be the focus, but obviously it's something we're going to keep researching. If someone comes up with a good way of storing it and producing it, then absolutely yes. I think people would definitely use that for interstellar travel or even interplanetary. I don't think anyone would ever let you actually use it for rocket ship engines on the surface of the Earth, although maybe not if it was small quantities. Question. I've read about using rotating rings of matter to generate gravitational fields that can accelerate spaceships to high speeds. Will you be covering this in future videos? I'm actually not familiar with that idea. I'm not sure how that would work with conventional matter. Maybe with something exotic like negative matter, but I'll look into it, and if it sounds like something we can do, we'll take a peek at it. Question. Are you worried about Kessler syndrome making us planet-locked? No. It's a big concern. It's something that we have to deal with as we start building up our infrastructure in space, but it is manageable. And most of the situations where you'd actually have enough stuff in space to have to start worrying about that kind of implies that you've got enough ground-based launch infrastructure to be able to manage it. That is actually a concern if you're doing interplanetary warfare. If you're the invading fleet, you really have to worry about all the debris that's getting put up when you start blowing stuff up. And if you're the ground-based one, you have to worry about a raid that's set just to set off Kessler syndrome to basically, imagine somebody came by and gave your planet Kessler syndrome. That hurts because you blew up all that orbital infrastructure, but they're kind of stuck for quite some time until they clear that, where they can't do much anything else. But we did discuss was it the space infrastructure episode in Upward Bound, some of the ways you can go about clearing that, and they should be pretty feasible. I really don't expect that to be something that would ever keep us planet-bound. It could just be a temporary inconvenience. Question, would micro black holes be easier to make than antimatter? It depends on what technology you get. The trick to making a micro black hole, the thing you really need to be able to do for that, to make it reasonable, is to find some kind of material that can actually reflect gamma rays or act for a lens as gamma rays, because you need to be able to use something that short of a wavelength to be able to produce a Kugelblitz black hole very reasonably. I've seen some other methods that involve basically an imploded nuclear detonation. Many of them around. They're kind of like how we set off nuclear bombs in the first place. We'll have to see, but which one's more realistic? Well, we've already made antimatter, so I'd have to say it's got the head start in that regard. Question. What do you think of computing other than using electronics? I'm going to assume you mean something like a mechanical computer that relies on basically switches made out of something like carbon nanotubes. That's got possibilities in it. You'd really have to ask computer scientists about which one would be more optimal, but whatever you can actually make smallest that can switch fastest, because that does matter. If it takes too long for it to change state, that becomes an issue. If it can do it smaller, if it can do it faster, or if it can do it with less heat produced, then it becomes a better option. Although there will also be a few cases for extreme environments where you might want to use a mechanical computer. We've got about 5 minutes left to go here. I'll take questions, and then we'll just do a quick follow-up on schedule. How far away in years do you think we are from creating von Neumann probes, and do you think it would be something that would be financially, ethically feasible? That's actually in the Seeding Stars episode we'll finish the year out with. Von Neumann probes, in their conventional sense, I don't think is something you'd ever really do, just because it's not very controlled or useful on the surface of it for colonization. It represents a certain amount of difficulty, ethically especially. Certainly variations of that, though, that are more controlled, yeah, but the idea is a von Neumann probe is an unmanned spaceship. The problem is if you've got an artificial intelligence in there sufficient to be adaptable, it's not really unmanned anymore. There is a person of some sort on board. And ethically, that's a bit of an issue. And there's really no right or wrong answer on that. I think we did talk about that in one of the recent episodes, is how ethical is it to make something that was designed to be a probe, for instance, that actually enjoyed that process. And that, again, that's an ethics question I don't think anyone can really give you a firm answer on. And question, you prefer teaching to research akin I guess that would be akin to teaching and research. I guess I do prefer teaching over research. I actually used to hate teaching when I was doing it in grad school. Most of my students, and I complain about that to a lot of my friends who actually have to teach, and they always tell me I should count my blessings. When you're teaching in grad school, you usually are assigned to teach the college physics 102 course, which is usually full of pre-med majors who are doing their very last semester. So they're there to work, they get stuff done, they don't complain much, and they're usually fairly smart and educated at that point. That's kind of the ideal student for someone who doesn't want to be there. and yet that bugged the heck out of me. You know, my friends who teach high school or things like that often really hate having to try to get enthusiasm with the students, and I'm sure it would drive me insane. I like having an audience that enjoys the topics we cover. That's they are voluntarily to learn, and so I couldn't even say that I necessarily like teaching, because part of teaching is by definition teaching people who don't necessarily want to learn the topic. But research, I mean, there's obviously a lot of research in anything you're doing at like this level. You have to do your research in advance, but the idea of spending years and years on a single project, I think obviously if I got really into it, it's when people are working on their doctorate, they often get very into the topic. It does kind of become their life, and so they have no problem staying motivated about it. And that might have happened for me on a given topic. I did not like the one I was working on when I was in grad school, and that was a big factor on why I left. Maybe a different topic I've enjoyed, and so I just enjoyed researching, but I did not happen to enjoy that, so maybe I would have enjoyed other things. Question, what do you do currently other than awesome videos? That's probably a good closing question to close out on for you to schedule and things, since it is relevant at the moment. My day job, so to speak, is the chairman of the Board of Elections for my area of Ohio, and we have an election coming up in 9 days, which is going to keep me very busy for the next week or so, and it's part of the reason why we're not doing this on the last day of the month, but picked for the weekend. Plus, I didn't want to do it at the same time as Halloween. And we probably will keep the last weekend for these. I don't know, it's just from my background, democracy is very important to me. And voting, just in general, is very important to me. And if you haven't voted this year and you are able to vote, assuming you're in the United States, please, well, it's too late to register in most cases, but please do go vote for whoever it is, even if you're just going there to vote for a few things. And, it's the most worthless vote is the one you never cast. So yeah, that does tend to take up a fair amount of my free time right around November, and except in presidential years in May. So we'll be coming up on that, and I'll probably be very exhausted for next week. But don't worry, the episodes are all written a couple months out, so they'll all be coming out at the normal time. And speaking of upcoming episodes, we do have coming up on the list. The next episode, as we say, is The Science of Aging, which we're going to be working with SENS Research Foundation with. By the way, as a side note, I'll often say the SENS Research Foundation. It is actually SENS Research Foundation, no the. But I still use both back and forth a lot. Episode after that is Reclaiming the Desert. That's the Earth 2.0 series, third episode. And then we have The Battle for the Moon, which is our book of the month, Artemis by Andy Weir, which is a fun one. And in case you're wondering about that, that is... Well, actually, I'm not going to spoil the episode. We are looking at many aspects of it, not just military conflicts on the moon, but we do include military conflicts on the moon. Then we'll be getting to our Return to the Generation Ship series, kind of. The fifth episode of that is going to be Sleeper Ships, which are technically not Generation ships, but it seemed appropriate to include it in the series. And that will be coming up on November 22nd. And we do have a fifth episode for November, 5 Thursdays that month, which is Megastructures, Flat Earths. And again, that is not about the Flat Earth theory. And then, of course, as we move into December, we've got some great episodes, starting with a kickstarting space industry, where we're going to ask ourselves a lot of questions about what could actually be the tipping point to get us really into space in a big way. And you'll get to see all those episodes before we get to see you again for our third live stream. I think we probably will not bring a guest on for November, though I might make some inquiries. And then, of course, December one would be that would be the very end of the year, so I'm not sure if we'll do one for December. But we will probably start bringing guests on for these at some point. Although I might test it with probably somebody close to home who I have fun with, who won't mind if I mess up and glitch the electronics. So, speaking of that, thank you everyone for joining me today, and hopefully we will be able to incorporate some more fun visuals and other things into these as time goes on, but we're still in novice phase at the moment. And I will see everybody on Thursday.